Hey there, Ravens. We're back for episode 5 of the gas laws, and we're going to talk about Boyle's law and the homework problems. All right, so hopefully you have tried out the homework problems and you're just watching this video to get a sense of if I did them right. Okay, so if the pressure exerted on the gas in a weather balloon decreased from, so that means P1 is equal to 1.01 ATMs from atmospheres to P2 is equal to 0.562 ATMs. As it rises, by what factor will the volume of the gas in the balloon increase as it rises? Okay, so this time we're looking for what's the factor of the difference between these two, okay? The factor being the ratio. So we're looking for factor volume will increase, okay, as it goes up. So we know that P1 times V1 is equal to P2 times V2. Okay, well, if I'm looking for the relationship between the two different pressures, right, if I divide by P2 and I divide by P2 over here, I'm going to get P1 over P2. And I could do the same with the V1, okay, over V2, right? And my, whoops, this should be a 1, not a 2. Okay, and then my V1s are canceling and my P2s are canceling. And what I end up with then is P1 over P2. That ratio is equal to the ratio of V2 over V1, right? So I just rearrange things. And basically, I want to know, what I'm being asked to find out is, what is this ratio? What's that ratio? Well, I can do that by taking P1, which is 1.01 ATM, divided by the P2 value, which is 0.562 ATMs. And when I divide those two numbers together, I get, there we go, 1.80 when I round. Okay, when you do that in the calculator, it comes out with 1.79 something. Okay, so in my ATMs cancel. So actually I'm not writing anything there. So the factor is 1.80. So the pressure is going to decrease by a factor of 1.8, and therefore the volume will rise by a factor of 1.8. Okay, so factor volume will increase is equal to 1.8. Okay, so whatever the initial volume is times 1.8 will give you the final volume. Okay, the second problem is a little more classic in what we see. So what pressure in atmospheres is required to compress a volume of 1.00 liters of a gas that is at a pressure, that's millimeters of mercury, so that's a pressure volume. So that's going to be P1 at a pressure of 760 millimeters of mercury. And we want to compress it to a volume, V2, of 50.0 liters. Okay, so this is Boyle's law. What are we looking for? We are looking for pressure. So we're looking for P2 is our question mark, and it's wanted in atmospheres. Okay, well my original pressure is not in atmospheres, so I am going to need to do a conversion. Okay, but now here's the thing is that I know that 760 millimeters of mercury, if you go back to page 1 of your notes where you have all of your pressure readings written down, all your pressure values, 760 millimeters of mercury is equal to 1 atmosphere. Okay, so that equals 1 ATM. So this is the value that I'm going to be using for P1 so that I can get an answer in atmospheres for P2. Okay, formula. How am I going to get there? P1 times V1 is equal to P2 times V2. This time I'm looking for P2, so I'm going to divide by V2, and if I do it to one side, I got to do it to the other side. And that means that P2 is equal to P1 times V1 divided by V2. And I just plug my variables in. P1 is, remember we're using the 1 atmosphere because we want our answer to be in atmospheres. And then we want our V1 is 1 liter. And then our volume, V2, is 50. Oh, 50 milliliters. Whoops. That's 50 milliliters. Okay. Well, then I'm going to have to make some changes here. This cannot be liters up here. If this is 50 milliliters down here, I need to have milliliters up here. But I know that 1,000 milliliters is equal to 50 milliliters. Okay, so those two will cancel, right? Milliliters and milliliters cancel, and I'll end up with ATMs. And so I do 1,000 divided by 50, and that's 100 divided by 5, and that would come out to 20 ATMs. And that is my final answer. V2 is equal to 20 atmospheres. All done. All right, next episode is Charles's Law. See you soon.